Once again, I welcome you all for Science and Technology Part 2, Standard 10. Students, we will be continuing with chapter number 5, Towards Green Energy, Module 4. My name is Ms. Jagjeet Kaur. Students, before beginning with the module, let us see what are the learning objectives. So today you all will be learning about electric energy generation using solar energy. So under that you all will be understanding what is solar photovoltaic cell, then connections of solar cell. Now in connections of solar cell you will be understanding solar cells connected in series and the solar cells connected in parallel. Then you all will be understanding about solar panel and the advantages of solar energy and problem of solar energy. Then you all will be understanding about solar thermal power plant. So before beginning with module 4, let us recall what we have studied in module 3. So students, we studied that fossil fuels like coal, natural gas and nuclear fuels like uranium and plutonium are hazardous and are polluting. Then we studied that the formation of fossil fuels such as coal, hydrocarbons, crude oil and natural gases like LPG and CNG. LPG is liquefied petroleum gas and CNG is compressed natural gas. Took millions of years to form. Then electricity generation from water reservoir, wind, sunlight, biofuels, etc. are eco-friendly alternatives of energy production, and these energy sources are never ending and do not lead to any environmental problems. Then electricity generation through these sources can be called environment friendly, and energy generated from sources which are unlimited and environment friendly is called as green energy. Then green energy sources are called so because they are naturally replenished and do not cause any harm to the environment. Then we also studied that hydroelectric energy is a conventional type of energy. Then in hydroelectric power plant, potential energy in water is converted to electrical energy. Then electricity generation using wind energy is done with the help of a wind turbine, and the kinetic energy of wind can be converted to electrical energy with the help of a wind turbine. Then wind energy is a clean energy source, but due to wind velocity problems, its use is limited. Now let's learn about electric energy generation using solar energy. Now students, solar energy can be used to make electric energy in the following two ways. That is, using radiations from the sunlight without using a transformer. It is trapped directly into solar photovoltaic cells, and electrical energy is produced from solar energy due to direct conversion occurring in photovoltaic cells. Then solar energy is converted into thermal energy initially and later by driving turbine generator system. By that, thermal energy electricity is generated. Now students, let's learn about solar photovoltaic cell. Solar photovoltaic cell converts the solar radiation energy directly into electrical energy, and this is called solar photovoltaic effect. And also the electrical energy generated through this energy transformation process is DC in nature. DC means direct current, and these solar cells are made of a special type of material called semiconductor, for example silicon. Now we'll take an example that a silicon solar cell of dimension 1 centimeter square generates current of about 30 milliampere and potential difference of about 0.5 volt. So thus, a silicon solar cell of dimension 100 centimeters square will generate about 30 milliampere per centimeter square multiplied by 100 centimeter square. That will be equal to 3000 milliampere current. And now when this 3000 milliampere is being converted into ampere, we will be getting as 3 ampere current and potential difference as 0.5. Now students, you have to remember that the potential difference available from a solar cell is independent of its area. Now students, let's learn about connections of solar cells. Now the first connection is that solar cells are connected in series. So when two solar cells are connected in series, the potential difference obtained from both the cell is sum of the potential difference of the individual solar cells, and the current generated from combination in series is equal to the current from an individual cell. And when solar cells are connected in series, currents from the individual cells cannot be added. Now let's see about the solar cells connected in parallel. Now when two solar cells are connected in parallel, the potential difference obtained from this combination is same as the potential difference obtained from individual cells. That means the potential difference will be equal to potential difference of cell 1 is equal to potential difference of cell 2. And the potential differences cannot be added when the combination is in parallel. And the current generated from two cells in parallel is the summation of the currents from an individual cell. Now students, let's learn about solar panel. Now solar panel are formed by connecting many solar cells in series and in parallel, and the desired potential difference and the current can be obtained by making solar panels by connecting solar cells in series and in parallel. Now, solar cell is the basic unit in solar electric plant. Now, many solar cells come together to form a solar panel. Now, many solar panels connected in series form a solar strings, and many solar strings connected in parallel form a solar array. And as we obtain as much electrical power as needed, they are used in applications which need marginal power to power station of megawatt capacity. For example, calculators that run on solar energy. Then the power available from the solar cells is DC. Now what is DC? DC is the direct current, and it is the one directional or unidirectional flow of electric charge. So in applications which need DC power, example electric lights based on light emitting diodes, the energy can be directly used. Since the energy from solar cell is available only in the presence of sunlight, the energy has to be stored in batteries for use at later time. And however, most of the equipment in domestic as well as industrial use run on AC power. And in such case, the DC solar power must be converted to AC power using an electronic device called inverter. Students, know what is AC power? AC power is alternating current power. It is the standard electricity format that comes out of the outlets. And we have seen that many solar panels can be connected together to generate whatever energy is needed. And also the DC power generated from these panels is first converted into AC power. A transformer transforms the voltage and current levels of the generated power, and then it is fed into the electricity distribution network. So in this way, the electricity is generated without any fuel combustion and so without any air pollution. Now let's see what are the advantages of solar energy. Now solar energy is a renewable source of energy, and also electricity is generated without any fuel combustion, so there is no air pollution. That means solar energy does not cause pollution. Now what are the problems of solar energy, or we can say the limitations of solar energy? Solar energy is difficult to employ. Employ means to use. And solar energy cannot be used at night or on cloudy days. And solar energy is not available uniformly during the daytime and at all the places on the earth. Students, we have seen that thermal energy generated from coal and nuclear fuel can be used to generate electricity. Thermal energy can also be generated from solar radiation and can be used for electricity production. So now let's see the different stages in solar thermal power plant. Now students, in solar thermal power plant, solar energy from sun is converted to electrical energy. A solar thermal power plant consists of a solar panel, a condenser, a turbine, a generator, pump and a cooling tower. The solar panel consists of many reflectors that reflect and concentrate solar radiations on absorbers, thus converting the solar energy into heat energy. Using this heat energy, steam is generated, and this steam is used to drive the turbine, which in turn rotates the generator and electrical energy is produced. Then the steam is converted back to water with the help of the condenser and cooling tower. Once the steam is condensed back to water, it is recirculated back to the solar panel. Now students, let's understand about the energy transformation in solar thermal power plant. Now in a solar thermal power plant, sunlight is used as a source of energy. And the first step in the energy transformation is the conversion of solar energy from sun to the thermal energy. In this step, the solar energy from the solar radiations is converted into heat energy with the help of solar panels. Then the next step is conversion of thermal energy to kinetic energy in steam. In this, the heat energy is used to generate steam, which is directed on the blades of the turbine. Then after this conversion, there is a conversion of kinetic energy in steam to kinetic energy in turbine. And in this step, the kinetic energy produced in the steam is then used to run the turbine. Then there is a conversion of kinetic energy in turbine to electrical energy. And in this conversion, the turbine rotates the generator connected to it, which in turn produces electrical energy. Students, now let us summarize what we have learned in today's module. So we learned that solar energy can be used to make electric energy in the following two ways. And the two ways are using radiations from the sunlight, without using a transformer. It is trapped directly into solar photovoltaic cells, and the electrical energy is produced from solar energy due to direct conversion occurring in photovoltaic cells. Then solar energy is converted into thermal energy initially and later by driving turbine generator system. By that, thermal energy electricity is generated. Then in the process of a solar photovoltaic cell converting solar radiations energy directly into electrical energy is called photovoltaic effect. And in solar panels, many solar cells are connected in series and parallel combinations to generate the required current potential difference. Then we also studied that in series combination of solar cells, the potential difference is the addition of the potential difference of the individual solar cells, while the current is equal to the current from an individual cell. And in parallel combination of solar cells, the current is the addition of the current of individual solar cells, while the potential difference is equal to the potential difference from an individual cell. Many such solar panels are then connected in series to form a solar string, and many such solar strings are further connected in parallel to form a solar array. Then the required amount of energy can be generated. Then we studied that a transformer is used to transform the voltage and current levels of the generated power and is then fed into the electricity distribution network. And in solar thermal power plant, solar energy from sun is converted into electrical energy. Now students, find out by gathering information about major solar photovoltaic power generating plant and their capacity in India. So here we have gathered only very few, that means 4 to 5 solar photovoltaic power generating plants. So the first power plant is Kamuthi Solar Power Project. It is in the state of Tamil Nadu with a capacity of 648 megawatt. And the next power plant is Sakri Solar Plant. Sakri Solar Plant is in the state of Maharashtra and the capacity is 125 megawatt. Then the next is Welspun Solar MP project. It is in the state of Madhya Pradesh and generating the power of 151 megawatt. Then the next is Dhirubhai Ambani Solar Park. It is in the state of Rajasthan and the power generation is 40 megawatt. Then the next is Bitta Solar Power Plant. It is in the state of Gujarat and generating 40 megawatt capacity power. And students, there are many more solar power plants in India. So you have to find out the remaining solar photovoltaic power generating plants and their capacity in India. Now students, there is an assignment for you all. The first question for the assignment is draw a flowchart showing energy transformation in solar thermal power plant. So yes, the flowchart for showing energy transformation in solar thermal power plant is this. So here first the solar energy from sun, that means the sunlight is used as a source of energy, and then the conversion of solar energy from sun to the thermal energy. Then after that there is a conversion of thermal energy to kinetic energy in steam, and that then the conversion of kinetic energy in steam is converted to kinetic energy in turbine, which is used to drive the turbine. And then there is a conversion of kinetic energy in turbine to the electrical energy. Now students, the next question for your assignment is draw a flowchart showing different stages in solar thermal power plant. So yes, the flowchart for showing different stages in the solar thermal power plant is this. And here the solar panel consists of many reflectors that reflect and concentrate solar radiations in the absorbers. And they convert the solar energy into heat energy. And then this heat energy is used to generate steam, and this steam is used to drive the turbine, which in turn rotates the generator and the electrical energy is produced. Thank you, dear students.